Hey everyone, welcome back to my YouTube channel. Today we are going to solve one of the most popular binary tree problem asked in coding interview, path sum, part 3rd. We will break down step by step and explain the logic and implement it in Python. So make sure to stick till the end and do not forget to hit the like button and subscribe to my YouTube channel for more coding tutorials. So let's start by understanding the problem. You have been given a binary tree and an integer target sum, and we need to count how many downward paths from parent to child have a sum equal to target sum. And there are some rules in it. Paths don't have to start at the root, and paths don't need to end at a leaf, and they must only go downwards in the tree. For example, here, this is our example one. We can see 10 has been excluded and 3 and minus 2 have been excluded. There is one path that is 5 comma 3, and then there is another path that is 5 to 1, and there is another path minus 3 and 11. So all these paths have sum equal to 8. So our total output should be 3. Now let's discuss how to solve this. There are two ways to solve this one. There is a naive approach, that is brute force. For each node we will explore all possible paths starting from that node, and this works out, but it has big O of n square time complexity. That is very time consuming. Here we will be using optimized approach with prefix sum, but let's discuss what is that. We use a hash map to store the prefix sums we have seen till now, and for each node we will check if current sum minus target sum exists in the map. If yes, it means there is a path that gives the target sum. This brings down the time complexity to big O of n. So let's implement it in Python. First of all, we will have a base case, that is prefix equal to 0 and 1. This is a base case to have a sum 0, and we will return self dot dfs comma root comma 0 comma target sum comma prefix, and then we will define another function called dfs, and we will create self comma node comma current underscore sum comma target comma prefix, and then we will check if node is not null. That means if not node, then we will return 0, and then we will update the current sum plus equal to node dot val, and now we will start counting paths ending at the current node. Let's see. Count is equal to prefix dot get current underscore sum minus target comma 0. Okay, and now we will update the prefix sum counter. How can we do that? Prefix of current underscore sum equal to prefix dot get current underscore sum comma 0 plus 1. Now we will recurge into the children of the current node. Count plus equal to self dot dfs, and for this time we will be traversing through left child of the current node, that is self dot node, and then current sum comma target comma prefix, and now I will traverse through the right node of the current node. Count plus is equal to self dot dfs, and in bracket node dot right, and again current underscore sum comma target comma prefix, and now we will backtrack to remove the current sum. Prefix of current underscore sum minus equal to 1, and at the end we will return count. Now let me try to run it and check if it passes these two test cases or not. As we can see that it passes both test cases, and now I will try to submit it and check how does it perform compared to other users in terms of time complexity and space complexity. As we can see that our code passes all the test cases, that means 130 test cases in this problem, and it passes around 43.82% of users in terms of time complexity and around 97% of users in terms of space complexity. So if you liked the video and found this helpful, smash that like button and subscribe for more coding tutorials, and let me know in comments which problem you want me to cover next. Thank you for watching and I will see you in next video.